Mbak Evera, you can start the class today. Thank you.
Okay, thank you so much, Bu Nelis. Okay, good morning, everyone. The Honorable Lecturer, Dr. Renat Maya Sofitri, MSE, and all of the students here from Tarok Agricultural University and from ITS. Before I start, I want to say thank you so much for attending this class today. Okay, first I will introduce myself. My name is Evira Nadira Piasti. I am from Master Degree student from Biology ITS. Today I'll be the moderator for this class session. Okay, now we are going to have a lecture from Dr. Renat Maya Sofitri MSE about biofertilizer. Okay, before we begin the lecture today, let's pray for according to each other's belief. Okay, prayers begin. Okay, there are no words enough to pray. Thank you. Now I'm going to read the curriculum vitae for our presenter today, Dr. Renat Maya Sofitri, MSE. Okay, Dr. Renat Maya Sofitri, MSE, her field is about microbiology and biotechnology. For academic career, for doctoral in marine microbiology, is in Max Planck Institute for Marine Microbiology in Bremen, Germany. Start from 2005 until 2008. And then for master degree, number one is in marine microbiology in Max Planck Institute for Marine Microbiology, started from 2003 until 2005. And the number two for biotechnology is in Gajah Mada University, started from 1994 until 1997. And for bachelor, for pest and disease plan in Brawijaya University, start from 1988 until 1993. And for employment, now she becomes the lecturer for ITS, started from 1998 until now. And then for research and development projects over the last 5 years, number one is about smart automation and precision agriculture for Indonesia herbal plants in 2022. Then development of a UVC radiation-free sterilization system, and then technology for backlog waste conversion technology, and then technology of lyophilization and immobilization for dried acne with a long lifetime and high viability, and then finance waste application, and then converting finance waste becomes commercial soil fertilization, and then effect of Pseudomonas and Bacillus indigenous and bacteria in degrading plastic at a field scale application. And then for industry collaboration for over the last 5 years. Number one is improving the quality of edamame at PT Gading Mas Indonesia Teguh, Jember, Jawa Timur 2021 until present, and then converting industrial waste becomes environmental friendly waste at PT Ajinomoto Mojokerto Prokpetus 2022, and then improving the existing biofertilizer at PT Petrokimia Gresik East Java 2022. And then for important publication over the last 5 years, number one is application of rhizobacteria and NPK for growth and productivity of sweet corn. Number two is novel carbonatogenic bacterial strain isolated from limestone quarry in East Java. And then the next is the effect of tryptamine on Cerateria marcescens, Pseudomonas, and Escherichia coli. And then the last one is the effect of mixed biological pre-treatment and PEG on reducing sugar production. And then the activities in specialist biodies over the last 5 years. Number one is in Research Center for Infrastructure and Sustainable Environment ITS for microbiology expert, start from 1994 until current. And then number two is the Research Center for Agri-Food and Biotechnology ITS for as a CIF, start from 2020 until current. Okay, that's for Ibu Dr. Renat Maya Sofitri, curriculum vitae. And then We will start the class today. Okay, for Ibu Maya. Okay, the time is yours.
Okay, thank you so much for your long introduction about me, Mbak Elvira. Okay, hello everybody, good morning. How are you? Okay, now I'm quite happy that I have the turn now. Come to you, visit you face to face, even through the laptop in front of me. Maybe next time we can meet directly because we still have opportunity to meet each other. Because based on our agreement, if I'm not mistaken, we have a collaboration and there is still a possibility if you would like to visit us doing something in ITS because we have a lot of project and we can create this one together. Okay, now I would like to start dealing with the topic now because dealing with the biofertilizer. But better, before I start, I would like to know each other because mostly you are now really off cam. I just read your name. Okay, mostly only mostly I can read here is only TAU Jason, TAU Maybilla, and also TAU Aaron Rax. It is possible to just have a short time to see your face. It is okay. You just off on cam. Could you please do on cam? Okay. Rico, this is from biology. Okay. Hi, Maybelline. Nice to see your face. You are really sweet. Hello. And also, how are you, Maybelline?
Good, ma'am.
Okay. This is correct when I just call you Maybelline. Oh, you have a nickname?
It's okay, ma'am, if you call me maybe.
Okay. What is your nickname exactly?
Mabes po.
Sorry?
It's Mabes.
Oh, Mims. Okay, nice to meet you, Mims. Okay, now I can see the face of Aaron. Hello, Aaron. How are you?
Hello, ma'am. I'm good.
Okay, thank you so much. You are now in the class or you are at home?
Home, ma'am.
Okay, now what is it exactly in your institution? You have a big semester?
Ma'am?
Now is it you have a big semester? Semester break, I mean.
Yes, ma'am. Yes, ma'am.
Okay, okay. Nice to meet you, Aaron. And also I can see Jason. Correct, Jason?
Yes, ma'am.
Okay, how are you, Jason? How I call you? This is correct, Jason? Or John
Yes,
or Santos?
Jason, ma'am.
Okay, Jason. Nice to meet you, Jason.
Thank you too,
And
ma'am.
also I see Matt. How are you, Matt?
Hello,
Hello,
good
Matt.
morning.
Okay, you still unmute, Matt. Hello, Matt.
Hi, ma'am.
Okay, hello, Matt. You look very young. How old are you? Is it okay when I ask your age?
Yes, ma'am, it's okay. Ma'am, I'm 22 years old for now.
20 years old. Oh, you are very young from your face. Nice to meet you, ma'am. Okay, now
Nice to
thank
meet
you for visiting us through the online meeting. And now I meet also the Carl Dakumos. This is correct? Carl Dakumos.
Yes, ma'am.
Okay, how are you, Carl? You look so... Are you outside? Where
I'm
are you,
good, ma'am. Yes,
Dakumos?
ma'am.
This is really nice having you outside.
Yes, ma'am.
Okay. Okay. The committee would you please the remove the okay, now I can see the card directly. Thank you, card. And also I can see Melkor. Melkor?
Yes, ma'am. Melchor, ma'am.
Melkor. Oh, okay. Okay, Melkor, how are you? Fine?
I'm okay, ma'am.
Okay. I have a question. You have a long hair? Is it allowed
Yes,
in your institution having a long hair for student? It is okay, allowed in your institution?
thank you, ma'am.
Okay, nice to meet you. Okay, now Rico. Rico, are you from biology or biology Tau, correct? Tarlac University?
Hi, ma'am. Yes, po. Yes, ma'am.
Okay, how are you? You look also young, Rico. How old are you?
I'm 22 years old, ma'am.
22. Okay, 2-2. Wow. And you are in which semester now?
Yes.
Are you in the which semester? The 5th semester, 7th semester?
I'm on my 4th year level.
Oh, you are now in the 4th year, meaning that the 8th semester. You close to finish?
Yes, ma'am.
Wow, congratulations. Yeah. Hopefully everything going running well and until you finish your subject. Okay, nice to meet you today. I would like to start my class hoping that you are really, I mean, this really morning. I don't know whether what is this time different between Indonesia and Philippines. We are in the same time. You are now in the 10 o'clock. Rico, you are now, we are in the same time.
No, ma'am, we are ahead 1 hour, ma'am.
You are now in the at the 8 o'clock and 9 o'clock and 11 o'clock.
Yes, ma'am. Here in the Philippines, the time is already 11:18.
Wow, 11 o'clock, close to have a lunch, you know?
Yes,
You
ma'am.
have lunch time. Okay, I would like to do fast now, yeah? Okay, students, because mostly from Indonesia people, I really appreciate for just take a look your face directly even through the Zoom meeting. I'm very happy and I'm thankful that you are now really patient following our project. I have say Lilu. How are you, Lilu?
I'm good, ma'am.
Okay, really nice having you also, Lilio. Okay, and also I have Effie Gay. Is correct, Effie Gay?
Yes, ma'am. Good morning po. Good morning,
Okay,
ma'am.
how are you?
I'm doing great, ma'am. How about you?
Sorry?
I'm doing great, ma'am. How about you?
Okay, nice to hear this one. And are you also the 4th year student?
Yes, ma'am.
Oh, you are all of the, maybe in this class, mostly you are 4th year already, yeah?
Yes, ma'am.
You're close to finish all the student. Okay, now
Hopefully,
please,
ma'am. Thank you.
sorry?
Hopefully, ma'am. Thank you.
Yes, I just, what is it? In Germany, I drücke my Daumen, meaning that I wish you all the best until you finish your study. Okay.
Thank you so
Now,
much, ma'am.
please just give me time to give you my PPT. Wait a minute, whether I have already opened my PPT. Okay, now, before I start with my things, I will start with you still remember we start our program with the pre-test? You still remember with this one? Okay, I will start with my pre-tests that have already answered by you at the previous time in this program. Okay, I will open this one by one. Biofertilizer. It is me, Maya Sofitri. You know well about me that have been already introduced by Mbak Evira. I'm working in biology since 1998. Now I'm close to 30 years already to the working for the biology department, and also now I'm busy with. I'm quite busy the last 2 years with the Agri-Food Tech Research Center, meaning that Agri-Food and Biotechnology Research Center. I will explain a little bit of dealing with this research center after we finish about our topic. Yeah. Okay. Now the first question. Biofertilizer is a fertilizer that contain. Who can answer this question, please? Answer. Just raise your hand. Please, the committee, just tell me who raised the hand because I could not follow. I'm not really able to see which one will raise the hand. Okay, Ella Fernandez. Oh, no. Ella Fernandez just entering the room. Okay, just please raise the hand. The number one, biofertilizer is fertilizer that contain A, B, C, D, or E. Okay, raise hand. Tuk, 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 tuk. Okay, Surabaya ITS, you can also raise hand. Okay, 2 participants raise hand, Nathaniel Hari and also Evergay. Okay, I will give Evergay first. What is your answer, Afigi?
I think my answer, ma'am, is letter C.
The letter C.
Live microorganism and macroorganism increase the availability of nutrients and stimulate plant growth.
Okay, Afigi is C. How about you, Nathanael?
Thank you for the opportunity, ma'am. My name is Satana from ITS. I think it's B.
You
Like
are B.
microorganism. Yeah.
Okay. Okay. Now dealing with the biofertilizer, which is really concerned with the microorganisms, which is really dealing with the microorganisms, the correct answer is B. This is really dealing with the microorganisms. But if in the C, this is the similar one, but here is macroorganisms. Okay, if the macroorganism here, if in the C, if the macroorganism dealing with what is it, charging in English? Can you help me? What is it, charging? A worm. Okay, soil worm. You know the soil worm? If it is dealing with the soil worm, it is really correct. But if with another things, for example, the co, you know co, if on the co is also, for example, co also get P, the P of the co is also one compound that also can enrich the soil. The co is not dealing with the biofertilizer, not dealing with this term. Okay, that means the correct answer is we are dealing with the microorganisms. Okay, applause for the Nathani. The second one, microorganisms can be tick tock. Oh, Maybelline, just you are okay, Maybelline.
Microorganism can be, it's letter A, ma'am. All are correct.
Letter E, this one, all are correct. Okay, I invite Fauzi Satrio Wicaksono.
Thank you, ma'am. Good morning. Am I audible right now?
Sorry?
Am I audible, ma'am, right now?
Yes? What is your answer?
I think the answer is the letter D, A and B correct, including bacteria and fungi, also archaean process. Thank you.
This is your answer, correct?
Yes, ma'am, correct.
Okay, FG, you just raise a hand again. You have another option? FG?
No, ma'am.
No,
I
man,
just don't lower
just
my
lower
hand.
your hand. Yeah, lower your hand.
I'm so sorry.
Yeah, okay. Now I have Melkor. Melkor, you have another answer?
No, let's
Yes?
letter D, ma'am.
Sorry?
Letter D, ma'am.
Letter D?
Also letter D, ma'am.
Letter D. Okay. This is the correct one, is letter D. Why? Microorganisms. Just exclude the virus. Virus, until now, we are still question mark whether this is alive or something or thing, not a live one. Because the virus only have DNA and protein, but they don't have anything else. They only have, and the virus only live if they enter the host. Without host, the virus is just a kind of particle. That's why the answer is D. Okay, thank you. And then the third question. The advantages of the biofertilizer is, listen. Please, the committee, you can put the name who is really active. Maybe at the last session, the last program, the active student will give something souvenir from the biology. Okay, I see Fajrin Malik. And also I see Muhammad Habib. And again, AVJ. And again, Al-Fauzi. Okay, I deliver to Fajri Malik.
Okay, thank you for the opportunity, ma'am. Am I audible?
Yes, very clear.
Okay, my answer is the letter D, A and B correct. Thank
The
you.
letter D. Thank you, Fajri Malik. And Habib?
My I audible, ma'am?
Yes.
Yes, my answer is same with Fajri. Letter D, A
Letter
and B
D.
correct.
Okay. Fauzi?
Okay, ma'am. Thank you. I think my answer is same with Habib and Fajr. The letter D and be correct. Thank you.
Okay, thank you. And now for Afiji. Why mostly answer D as the correct answer?
Yes, ma'am. I've also answered letter D.
Why then?
It's because the biofertilizer is low cost and can be renewed and eco-friendly because it has natural uh, and it can improve the soil quality, and then but it is not easily handling because it has to do a lot of work, and
Okay,
it may
and
take time to respond.
this is correct. Why takes time to respond? Rico, can you answer? For the biofertilizer, we need time. And then, yes.
It takes time to respond because biofertilizers are come from microorganism, which this microorganism um is not easy to recreate because they're living in a expense of an environment.
Okay, this is really correct. This is really correct. That's great. I'm quite happy with this class. This is the correct one. Okay, still a question. Please lower your hand. Please lower your hand. I have another question here. The microorganisms as biofertilizer agent are belong to? Okay, I have to see who will be. Okay, I'm going to Stephanie Christina.
Morning, ma'am. I'm Stephanie from Biology ITS. My answer for this question is A and B correct. Nitrogen-fixing bacteria such as Azotobacter and the phosphate solubilizing bacteria can be a fertilizer.
Okay, which one? D or E?
D.
D. Okay, you choose D. Who else? Muhammad Akil, please. Akil.
Ma'am, it's
Not really clear your voice, Akil.
my audio
No, it's really
audible?
bad. This is really bad. You have what is it? Gemelan ya, pantulan suara kamu. Okay, you can try again. Which one? Okay,
Maybe D, ma'am, because I have read that ingredients of biofertilizer is alternative we know NPK. That's ingredients. There are nitrogen, phosphate, and potassium.
Okay, you only focus on NPK, yeah, NPK nutrient. Thank you, Akil. Nathaniel. Okay.
Thank you, ma'am. I think the answer is E, ma'am. All are correct.
All are correct. Good. Veronica?
Same as Nathaniel, I choose E, ma'am. All are correct.
Okay. You also choose A.
Yeah.
Now I would like to invite student from Philippines, Aaron. Aaron, why It is cellulotic microorganisms and phytohormone or auxin production bacteria really belong to biofertilizer agent. Why then?
I'm sorry, mom. I don't have idea.
Okay, you have no idea. It's okay. This no problem. This is really no problem. We are now here. It's just we just trying. We just learning now. Yeah. No worries about this one.
Yeah.
Okay. Again, who raise hand? Who will raise hand? I see another student raise hand. Okay, may I invite Rico again? Rico or Lilio, you have any idea? This is really correct that C, cellulotic microorganisms and auxin production bacteria belong to biofertilizer agent.
I have no also idea, ma'am.
You have no other idea, no worries. Okay, good, thank you. I go to, okay, better. I just, who raise hand? Who raise hand? Maybe Fauzi Satrio?
Yes, ma'am. I think the cellulotic microorganism and the hormone auxin producing bacteria is not including in biofertilizer agents because it's for the phytohormone. It's like not the biofertilizer component, I think. Thank you.
Okay. But first, I will put the answer. The correct one is E. All are correct. Because now mostly the student only thinking about the NPK as the nutrient for the soil and also for the plant. If we go back to the definition of biofertilizer here, what is it? Increase availability of nutrient and stimulate plant growth. What is it, plant growth? For example, plant growth is the auxin, the hormone. It's also important for the plant, and bacteria can produce the plant growth as well, and they extracted outside to the soil area and can be taken by the plant. And the one is the cellulotic microorganisms. Please, this is, I have one cases. I will also put these cases at the last slide, and you can see microbes, also biodecomposer. These cellulotic microorganisms or biodecomposer is also important as the biofertilizer, because the biodecomposer organisms, they will decompose big molecule to be very small or very simple molecules, and the simple molecules can be converted being N, being P, being potassium as well with another microorganisms. That's mean how to change the big compound becoming nutrient. We need more than one microorganisms. One, for example, here cellulotic organisms. The cellulotic organism will degrade cellulose, become simple carbohydrate, for example, glucose, and this glucose can be converted becoming pyruvic acid, and then pyruvic acid can be nitrate, potassium, and also can be N, kalium or phosphate agent with another cycle, meaning that this also belong to biofertilizer. Then the correct answer is E. Okay, clear enough? Okay, now the last one. You can see the picture really nice. Oh, okay. You can, what I have already explained here, EAA. Okay, and here many thing compounds around here can be then degraded becoming alpha ketoglutarate, butyrate, and this alpha ketoglutarate can be also degraded becoming amine, phosphate, and so on. This is a kind of the organisms working in order to provide many kind of nutrient that need by the plant. Then we go to the question. Wide variety of the mechanisms plant growth promoting rhizobacteria or PGPR is. Okay, I see two participants raise hand. Who? Okay, now I go to Fauzi Satrio.
Thank you, ma'am. I think the answer of this question is letter D, A and B, correct? Because
Yeah, there is no letter. I'm so sorry. There is no letter at all. This is that's which one do you choose? A, B, or all are correct?
A, B, correct. Because I noticed in the third option there is promoting plant microbes antagonism. I think it should be promoting plant microbes symbiosis because it should be like support each other to grow. Thank you.
Okay, this is totally correct. If without antagonism, symbiosis, just like you said, now this one will be correct. But unfortunately, there is an antagonism. No. Biofertilizer should be not antagonistic. Correlation between the organisms and the plant. Yes, should be symbiosis. Okay, now we are finished, meaning that thank you so much, meaning that this A and B correct. You have an idea how about your pre-test in the previous program? So the answer the same, the similar question, the similar answer for all the question. Oh, maybe you don't remember about this one, yeah? Okay, now I go to the biofertilizer. Biofertilizer, what is it exactly? In front of you, you can see this is how the soil, if we just cut vertically, like this. And you can see O horizon, A horizon, B, C, and R horizon. What is it exactly? Mostly this horizon just give us the information about what kind of nutrient inside this layer. We just put in the 1, 2, 3, 4, 5 layers. And the numbers of layers depend on the kind of soil and which area you take the sample. It's quite different between one area and another area. But if it is only for general, if we just cutting the soil in the vertical things, you will get the layer just in front of you, A, B, C, and R. Yeah, okay. And again, based on the soil, if you take a look this diagram, these three diagram, yeah, this layer, they just mentioned that the soil will be ideal for the plant. For example, if 45% content of mineral, 5% content of organic compound, and 25% content of air, yeah, there should be a pores inside, and this gives the opportunity for the microorganisms who are really aerobic organism for breathing there, and also content of water, 25%. This is ideally. And if not ideally, you can see the comparison between the compact one and also poorly dry. If it is poorly dry, meaning that the air is less, only 5%, and the water occupying 45%. From this percentage of the component of this area, how many percent exactly for the microorganisms? Only 1%. This one, only 1%. Even we mentioned, many papers said microorganisms are found in the soil, very high numbers. Very high numbers, but they are only make up less than 1% of soil volume. You can imagine, only 1% can maintain the nutrient inside the soil here. Meaning that less than 1% and how poor the soil is. Okay, now this is the example of what is it exactly the group of the bacteria inside the soil. They are going to the bacteria group, actinomycetes group, fungi, algae, protozoa, and also even virus. If virus is not belong to organisms, but you see here, the virus should live together with the tobacco plant. Okay, yeah. And how about the bacteria? Now we goes to directly to the bacteria. The bacteria goes to this. And this is the bacteria. Yeah. Okay. How about the bacteria? The bacteria goes to this genus. Arthrobacteria, Bacillus, Pseudomonas, Agrobacterium, Alkaligenes, Flavobacterium, Corynebacterium, Micrococcus, Staphylococcus, and so on and so on. And you can see the percentage of them. This is one study that have already published. Yeah, you can see here, this is the source. You can take a look at the source. Yeah, you can take a look at the source. What they said, this is meaning that only 1% the bacteria, or not the bacteria, the microorganism can help the soil maintain the nutrient inside. If it is less, meaning that, whoa, how poor the soil is. Okay. Even this is less than 1%, that I mean that one, these microorganisms really maintain the soil fertility. If it is less, the soil become infertile. And how the farmer is, this is really quite famous now. The farmer only use inorganic fertilizer, chemical compound. And you see, what is it exactly impact of the chemical compound if we use regularly for a long time? You can imagine what is it, the impact for our environment? Okay, Lilo, what is it, the impact if we are using the chemical fertilizer for a long time? Especially we are dealing with the focus on our environment. Yeah? What is it? Lilo?
Yes, ma'am.
Yes. What is it, the impact of our environment then?
Will damage the soil, ma'am.
Okay, damage the soil. What is it, the damage of the soil? You can imagine what kind of damage? Okay, FEG. I see FEG just raise hand. FEG is correct. FEG. I'm so sorry if I just wrong mentioning your name. FEG.
Yes, ma'am. I think it is the chemical contamination of the soil, or it will be high acidity.
Okay. Our soil become higher acidity, or become more base, more acid, or become more base. This is depend on what kind of fertilizer in what is it, the chemical compound fertilizer that you apply. This is really correct. The chemical character of the soil will be changed, and it's not really good, meaning that the soil become more harder, for example, more crusher, and not health anymore for the plant. Yeah, this is only one example. Many examples can be also explored if we use if you use chemical compound as our fertilizer. Okay, now I just go ahead. This I just dealing with the NPK only in this side. Yeah, this is the slide is only for NPK, but we have many things about this biofertilizer that can be provided by organisms. Naturally can be provided by microorganisms. What is it exactly? You know about what is it? The role of the potassium, the role of nitrogen, and also the role of phosphate. They are really important for our plant growth. Yeah. Okay. You see here, as I mentioned before, the microorganisms not only dealing with the N, P, and K, P and K, but they are also dealing with the organic compound, another organic compound. For example, auxin have been already mentioned, and here flavonoid, and also malic acid, and also sugar. This is the simple sugar. And also, what is it? Many kind here, as also we can see here another exudate hormone as well needed by the plant, then can be provided by microorganisms. really complex, our biofertilizer. And you can see, this is the source. You can read this paper. This is a really nice paper. Okay, now for example, biofertilizer, because now again dealing with the NPK only, but it is not NPK only. I would like to stress out what this one. If we are dealing with an N, we have rhizobium, we have azotobacter, we have azospirillum, and also we have algae. For the phosphate, we have also rhizobium, azotobacter, azospirillum, and also mycorrhiza. You know what is it? It's a mycorrhiza. This is one kind of the fungi who really live inside the plant in the root area. They make a nodule and they will extend. Seems just like pseudo root for the plant who has already mycorrhiza inside in the plant root. And also enriched compost. Here, enriched compost. We have cellulosic fungi. They just degrade cellulose that we discussed previously. This is a kind of biofertilizer. Yeah, many. And also biofertilizer dealing with the flavonoid, dealing with the hormone, dealing with another exudat, which is really important also for the growth of this plant. Okay, now going here. Type of microbial agent for the biofertilizer. Two types. They are symbiotic microorganism, meaning that they live inside mycorrhiza, for example, or free-living microorganism. They're living outside, but really close to this rhizosphere. They are really close to rhizosphere. That's why the exudate that have been produced by the organisms can be fastly taken by the plant. There are two types of the microbial agent as the biofertilizer. Okay, I have one example that have already performed by my student here. Previous one that have been already published. Unfortunately, this is in the title is in Indonesia, meaning that bacteria act as a biofertilizer for the infertile soil plant. We just isolated numbers of organisms, bacteria. Here we're focusing on bacteria, but we choose only 6 of bacteria here, and they have the ability to solubilize phosphate and also potassium. This is the ability based on the clear zone surrounding the colony. And also they have the ability to fix nitrogen here. And they have also ability to produce auxin here. And what is it exactly? You can see this treatment, this belong to this treatment. We only use our fertilizer, our organism, our bacteria. And this one, NPK, is our control. Okay, this is really clear enough. If we use NPK only without any organisms, the plant growing happily. This is because what? NPK can be what is it? Yeah, a chemical compound of NPK is really fast absorbed by the organisms. But if we use biofertilizer, we are dealing with the time. The response, we need time, not fast response. That's why we need time. But for growing the plant, we have limited time, only 70 days. That's why you can see here, even we don't use any kind of biofertilizer, we can still produce this. P3. This P3, what is it, P3? P3 consists of 3 different organisms. Yeah, 3 different organisms here. We can produce the sweet, what is it? Jagung, sweet jagung, bahasa Inggrisnya apa saya jadi lupa ya. What is it, jagung? Oh yeah, the sweet corn, thank you so much. The sweet corn as well. They really, you see the kernel here really compact with the control. Here is the control. No reason at all if we use the control. But we are trying to find biofertilizer who can produce the similar product as the inorganic fertilizer. But you can see here, meaning that if we use 3, bacteria, we can produce one. But meaning, if it is the size quite different 2 times, we have to maintain abiotic factors to make our bacteria more happier living inside our soil. This is a kind of question mark. This is another study that we have to improve with. Yeah. This one, isolated bacteria put positive impact to the endogenous microbes. So since they just give the higher performance of growth here. Yeah, and okay, we are not talking about the NPK. Okay, here we still, okay, this can be the conclusion of this work. I would say that this is one thing, because I read papers also, a kind of, okay, I would say this a kind of a little bit pessimistic, not really optimistic enough. They just said, the paper said, okay, we cannot 100% using biofertilizer. We have to combine biofertilizer and chemical fertilizer. We have to combine. Okay, now I just thinking about the one. How, if we are trying to combine, can we make similar size of this production? Basic and micro nutrient or containing fertilizer is still needed. We have to combine, especially in the generative stage. Are you still with me? My voice still clear?
Yes, ma'am.
Okay,
Yes,
very
ma'am.
good. Thank you.
Yes, ma'am.
Thank you. Now, what is it? The next work is, we would like to combine between biofertilizer and organic fertilizer in dual application. Okay, what is it? I got another microorganisms. I choose 5 microorganisms, bacteria, who is belong to. You can see after we are doing the 16S characterization, we have 5 different one: Bulgaria, Enterobacteria, Pantonea, and Bulgaria, Pantonea, and also Enterobacteria. 3 genus, but 5 different species. And we do like this. We just combine them. All these 5 become one consortium. And we just apply like this. Before we planting our soy, our sweet corn, we just try to, what is it, introduction of our organisms, of our consortium. I hear something. It is correct. You hear something also from your side? Noise? It's okay? Okay.
It's
Now
okay,
I
ma'am.
just continue.
Your voice is
Okay.
still clear.
Okay, thank you. Now, in the day before planting, this is the planting day. 3 days before planting, 4 days before planting, I put my biofertilizer. And then here, I put my plant here inside. And 7 days, I give NPK with the general dose. I just play around the doses of NPK. I make less 25%, less 50%, and less NPK 75%. Yeah, I just put different dose of the NPK. I put lesser than the suggested dose. And then I put again in the days of 21 and 31, I give again the biofertilizer. I do sampling about the soil. And then on the day 40, I put NPK again. And during the 65 days, I put only 2 times NPK with the less doses, but I put 1, 2, 3, 4, 5 times biofertilizer. Yeah. And what is it then? This is the result. Okay, you can see the result based on the plant height and based on the stem diameter. And here, this with this one, yeah, this one with this signal across, this is NPK 100% without biofertilizer at all as our control. And you can see that the control with our treatment, consortium plus NPK 50%, they meet here. And again with the stem diameter, they meet again. Even I only use less NPK, I only use consortium, they are meet. Meaning that even we apply less NPK chemical compound, but we apply biofertilizer, the growth of our sweet corn happily. They just similar that with the growth are similar with the control with 100% NPK. Okay, how about this is the product. You see, where is it? The control, K2 is control here. And this is our product. Aha, you can see here, similar. Yes, this is the control. This is our product. What is it? 75% NPK, 55% NPK, but here it's not really good. Meaning that we can use less NPK if we also put inside of our biofertilizer. Okay, then the conclusion. Yes, we can reduce chemical compound plus adding the biofertilizer, we have promising fertilization for our soil area. Nice to hear with this one, but our target is for the future, it is possible we go directly 100% bio with no chemical compound. Now it's really trending, yeah. We have a bioproducts of our agriculture product, but it's quite expensive because we put regularly our, we have a special treatment for our bio compound, bio product. Yeah, okay. Now, another one. Should we always mix the biofertilizer with the inorganic compound? This is one, reducing chemical compound. Should we always use it? I don't want to use anymore. For example, I want to ignore this. The previous study using the, using the sweet jagung tadi lupa lagi. Apa jagung tadi?
Corn.
Yeah.
Corn.
The sweet corn, it is not really possible if we don't use any chemical compound. Really? This is really? And then we have another study. You see that oyster mushroom, this is the planting oyster mushroom. We use this is planting medium. We call this one backlog. I call this one backlog. Yeah, in Indonesia, call this one backlog. Planting medium for the oyster mushroom. After finishing this, using this backlog, we have a lot of numbers of waste of the backlog. Yeah, we have many of this backlog in our surrounding. I just thinking how to use this backlog as the planting medium. Is it possible? And we use the Brassica sinensis as our plant here. I put here only microbial consortium who has the ability as the biofertilizer and also ability to cut, because this waste many of cellulosic and many of cellulose inside is the one compound. We put also cellulosic bacteria and also ligninotic bacteria. And what happened then? I am quite happy. This one, this control, just take a look here, control first. This control seems so sad to see that our plant, this one, Brassica plant, is not growing even have been 30 days. meaning that this one is backlog, the waste of backlog without any kind of microbial consortium. There is no fermentation. We don't put any bacteria inside. And you can see that the waste not support the growth of the plant. And how about the control? You can see here the control pass. The control, you can see this is what is it exactly the control. I use the soil here, just like you can buy soil in the farming in the farming shop, and you can buy the soil. This is really full and rich soil, and they are growing well. 20 days after planting, 30 days after planting, you can see here. But if we compare with our fermented one, this one, our fermented one, this one, plant heads here, they are really close to the control one, control positive. This one, the control positive, they are really not significant in supporting the growth of our brassica. This is belong to what is it? This plant is belong to horticultura. Yeah, this is for the vegetable. And how about the heads also? It is similar one. Okay, and then how about the NPK? We are only dealing with the NPK. This NPK, this one. Mostly the NPK, if we goes to the national standard of Indonesia, this NPK, this formula is really meet in our standard. And then, yes, even we are really dealing with the microbial consortium only, we can degrade this waste becoming planting medium. If we are using the plant is for the plant, vegetable plant, horticulture, what is horticultura? Yeah, horticulture plant. Yeah. Okay. Now we are dealing with the the advantages and disadvantages of the biofertilizer. What is it exactly? You see the advantages: increasing the availability or uptake nutrient, stimulate plant growth through the hormone, and antibiotic action. Now it is also dealing with the antibiotic, not only hormone, but antibiotic is also supporting the plant growth, cheap, and reduce cost of cultivation. And also improve the soil properties. They are more, what is it? The soil is not really stuck to each other, but the soil is really easy to, they are just easy to spread out. And then this one we can use for the long time because it is really eco-friendly and no damage at all for the environment. And disadvantages, this is only two disadvantages. We have many disadvantages of using chemical biofertilizer, but only two disadvantages if we are using the biofertilizer. Slow response, longer time, need to improve how to store them because they are living cell. We have to do something for our medium to keep them alive and just sustain their viability. Okay. Before I go to this one, how about this one? This is give you one new perspective about the biofertilizer, or you have another, you have something to comment, or you have something to discuss? Okay, I would like to ask the Filipina, are you also in your what is it, in your farmer in the Filipina is also really difficult to push them using the organic compound as their biofertilizer? Do you have an experiment with the farmer, directly to farmer, that you just give them knowledge to your farmer, and okay, the farmers, you please just use less chemical compound and try more biochemical compound, biological compound for fertilizer? And what is it there of the farmer comment if you give this suggestion? You have an experiment? You have an experience? Okay, Carl Dacomus. Okay, I see the Gil Luferiana Ersasi. Can I see your face, please? You still hide, you still outside. Okay, nice to meet you. Feriana, this okay? I just call you Feriana.
Hello, ma'am. Am I audible?
Yes, very correct, very clear.
Thank you, ma'am. Actually, my nickname is Gege.
Oh, JJ,
So-
okay.
Okay, thank you, ma'am. My name is Gege from Biology ITS, batch 2020. Thank you, ma'am. Based on my experience about when I'm around in high school, I have a project to write about traditional ways to what is it? It is part of my research about in a program called Kikigaki, but the responders are also farmers in Palangkaraya, Central Kalimantan. So it's not the main purpose of my interview that day, but I asked few questions about what kind of fertilizer that they use. And basically in Palangkaraya nowadays, about we have in the area of Tangkiling, the area what we call Bukit Batu here, people there usually use kind of mixed chemical and biofertilizer because there is kind of harsh environment there, and there's kind of different type of soil in there, and people tend to mix, or the farmers usually the farmers has kind of their own prescription, I must say, to use this kind of fertilizers because there are a part of the area in the farm that is from peatland, so it is acid.
Yes.
So therefore, they are kind of mixing the both the bio fertilizer and the chemical fertilizer, ma'am.
Okay, do you
Thank
know that
you.
there are, thank you so much for your experience, Mbak JJ. Okay, do you know that by biology, what is it, microorganisms also can increase the acidity of the soil? We can use also as well, but this is quite difficult to give the fast response. This is the point, is the fast response, how to improve the pH of our soil. Yeah, okay, that's nice having this one. It's okay, now I go to FEG. You have another
Hello,
comment?
ma'am.
Yes.
Am I audible?
Yes, very good.
I have no experience about using or using biofertilizer, but I've been talking to a lot of farmers here in our local. They are afraid on using, or they afraid to risk in using biofertilizer because of the improper, or they don't know how to they don't know what is the proper use or proper schedule in putting biofertilizer though, so they prefer using what is synthetic fertilizer.
Chemicals fertilizer.
Yeah, yes, ma'am. So maybe this OGT, or the knowledge that we gain here in the OGT, will help us to introduce this to the farmers. Thank you, ma'am.
Yes, this is really correct. That's why, as a student, we have to provide one dam plot, dam plot. We have to provide one area, and we give the farmer that we can also produce high quality yield, even we only use the biofertilizer. The question is how long we can do the dam plot, because normally if we do the dam plot in one specific area, it takes also time. Maybe before we can do a yield, before you do harvesting, you finish already with your study. Yeah, this is a question. This is a kind of challenge for you, all of you, to do this one as well, because you are going to be the agriculture scientist in the future. You have to push our farmer using the biofertilizer in order to keep our environment sustained. This is the most important things. But okay, if we are dealing with the farmer sometimes I don't need the biofertilizer because I need yield. I need fast. I need to get my money back fast. Yeah, that I invest already. This is two different, mindset. One is really focused on the environment, one is focused to the business. But why not? We can combine these two mindset, become one good win-win solution. The farmer is also get money and environment also get safe. Yeah. Okay. I go to another student. Rico, you have another. Thank you, Alpha J. And Rico, you have experience facing the resistance of your farmer if you suggest them using biofertilizer. Because I just asking this one because in my opinion, all of you now in the fourth year student, you are now fourth year student, you do already, what is it? We call here is KP, kerja praktek. How do you call this kerja praktek di dalam bahasa Inggrisnya itu apa ya? Apa Bu Naib kalau kerja praktek in English? I forgot about this. You have already do just like
Maybe job training, Ibu.
Yes, correct. You have already job training because during the semester you have do job training, go directly to the society. Maybe you have experience already to your society, farming society, doing a kind of work dealing with your knowledge. Okay, Rico, you have an experience doing the jobs training directly to the farmer society?
Hello, ma'am. I'm audible.
Yes.
Okay. Ma'am, as of now, so far, I have no experience about that. But here in our locals, I'm agree with my friend Aviji because they are afraid using biofertilizer, and instead they use NPK fertilizer. But correct me if I'm wrong, ma'am. Here in our gardens or small grower farmers, we use biofertilizers like carabao manure, or I'm not sure if it's part of biofertilizer, but we use carabao manure and um, chicken waste as a fertilizer, and we also use the eggshells and the processed cocoa peat manure, and by that we put that as a fertilizer in our growing crops. And I think that's it from me. Thank you, mom.
Okay, this is also biofertilizer using the organic, compost. You use the organic compost. This is really correct. This is belong to also biofertilizer. This organic composter that you can use as your additive for your soil area. This is correct one. And how about the yield? This is really good yield when the farmer using that one. They can also do harvest. How big the harvest after you apply that fertilizer?
The harvesting is still good, mom, as compared to NPK. There's no large difference, but it is good both using NPK and biofertilizer.
Wow, this is really nice hearing this news. That's mean now is our task to push our farmer, please just reduce the chemical compound in our environment. But this is not really easy. This is not really easy, I would say. This is really hard because the farmer only have a mindset that I have to get yield. I need to get my money back that I have already invest in our land. Yeah. Okay, Lilio. Thank you, Rico. Yes, thank you. Now I'm going to the Lilio.
Yes, ma'am.
Do you have any? What is it? Maybe this is not your directly personal experience. Maybe you just read from your newspaper about your farmer and how about the what is it? The policy of your country. That your country, maybe the policy of your country to push farmer using the biochemical, biofertilizer, for example.
Here in our province, ma'am, no one uses biofertilizer here because farmers are also because farmers are lack of idea on how to use biofertilizers. So they use more chemical fertilizers. Like
Small chemical fertilizer. What do you mean by small? This is under dose or? What do you mean by small fertilizer? Chemical fertilizer. What do you mean with this one? They applied with the lower dose or what is it?
Yes, ma'am.
They use lower dose of the chemical fertilizer?
Yes, ma'am.
Okay. And how about the yield?
Oh, good, ma'am.
Really good also as well.
Yes,
okay. What kind of the plant it is? Rice?
Yes, ma'am. Rice.
Okay. Okay. Now, thank you, Lilo. I'm going to Alfauzi. Alfauzi, maybe you read something, a newspaper, even you, maybe, I don't know, maybe you have also experience, as personal experience dealing with the biofertilizer, Alfauzi?
Yeah, ma'am. I think I have an experience about biofertilizer, especially for the third semester. I have like collaboration project made between IDS and IPB University. And here we combine micropropagation, like the explant plant culture and the biofertilizer. And we culture for gaharu. I don't even know there's English name of gaharu, but it's one of the vulnerable plant in Indonesia. And the gaharu is really good and for industrial and for the conservation. And but gaharu has like seeds that we cannot grow naturally because it would be like going eat by another bacteria, so it can grow very well. So we turn out to micropropagation methods, but in micropropagation, we know that the planet is like unstable, so we could exactly use the biofertilizer. And in here, I use mycorrhiza, trichoderma species, and also the compost. So we combine these three materials to produce the biomaterials for the plant until the gaharu or agarwood. I remember agarwood. It could be the good and for industrial and for conservation.
Okay, okay. This is now quite promising, but biofertilizer, correct?
So sorry, ma'am, I can really hear you well.
Okay, that means that biofertilizer is one promising fertilizer because you already applied to the gaharu. The gaharu is one hard plant. This is really hard plant, yeah. And for the gaharu also give good response if you apply it with the biofertilizer, correct?
Yes, ma'am, it's really correct.
That is okay. That is really good example then, meaning that if we are really patient using the biofertilizer, we don't have to be worried because my example that I already explained to you, is really dealing with the one that I explained. Dealing with the horticultura only. Yeah, only with the horticultura. But then Al Fauzi already mentioned that has the experience with the hard plant, the big plant can be used also, can be applied also as well with the biofertilizer, with any kind of organisms to support the Gaharu plant. This is really nice. Okay, I need also another opinion. Thank you. I again forget Al Fauzi Satria for your experience. It's really nice hearing your experience. Now I go to Jason. Jason, how are you? Jason. Hello, Jason. Are you still there? Okay, seems that Jason is now going to the shop buying a biofertilizer. Okay, now I go to Jimmy Boy. Jimmy Boy. Jimmy Boy, how are you?
Hello, ma'am.
Hi, Jimmy Boy. Do you have any experience, Jimmy Boy, with our topic? You are
Yes, ma'am.
Mhm.
Yes, ma'am. I have experience of biofertilizer.
Yes, just
In yes, in our local, ma'am. Because I'm a farmer.
Oh, okay.
Yes, I have an experience. For example, I have an experience for they use the biofertilizer as a basal fertilizer for corn. Then
what is it, the yield? You can harvest the yield really good compared with the chemical
Yes.
compound?
Yes, ma'am. Because this in our local, ma'am, they usually use urea fertilizer for basal. Then sometimes when I'm going to one of the farmers here, I experienced the organic fertilizer they use it for basal. Then I see, then later they use chemical fertilizer.
Okay, just the combine between. And do you
Yes.
know what is it that their opinion about the biofertilizer? They are really trust to the biofertilizer 100%, or they just want to combine with the chemical fertilizer?
Yes. I think they want to use low cost because I think organic fertilizer is low cost, so they nung Tagalog nung bayaw sa nung Tagalog nung pinalitan.
Na?
Yung pinalitan bayaw.
Change.
Yes, ma'am, because they change the urea to organic fertilizer, so I think they want low cost farming, sir.
Okay.
I think that's it. Thank you, ma'am.
Okay, really nice hearing is also as well your experience, especially you are the one player of you are also farmer, correct? You are the player, then directly player.
Yes, ma'am.
Okay, thank you, Jimmy. And now I'm going to another student. Okay, Matt Leonard. Hello, Matt Leonard.
Hello, ma'am.
Yes. Can you just video on?
Wait, ma'am. Can you see me, ma'am?
Yes. You have any idea? You have any comment compared with maybe you have another idea. You have another comment? Yes.
Mostly in our country, especially in our area, they use mostly chemical fertilizers because organic fertilizer or biofertilizer is not very common here, especially in our traditional farmers. They prefer mostly chemical fertilizers, but we use also vermicompost that produced by worms. And I think the best way to introduce it to our farmers is to have some seminars and also physical evidence to support that biofertilizer is very effective in farming. But I have also experienced, ma'am, personally. I have a garden here, and I use pigment combined with carbonized rice hull as a growth medium.
Okay.
And the product is actually good.
Okay.
I have a backyard garden here, and I plant some chilies now.
Okay. And you got the good yield of your chili?
For now, ma'am, they all, yes, they have a ano na to? Tawag doon. Wait, ma'am.
Okay, seems that
Yes,
delays.
ma'am, they are now in the stage, and they have also the flowers for now. But since in our season for now in the Philippines is rainy day, I think
Okay.
it's not appropriate to plant a chili in rainy days because some of my plants is they have like dwarfism like that, ma'am, and the leaves are very not actually that green. They have yellowish color because of the bacteria, or I think this is the pest. Because I don't use some chemical fertilizers or some pesticides, so I will go to organic planting. That's all, ma'am.
Okay, this is wonderful experiences from your side, Matt Leonard. This is really nice having this one. Okay, from my Indonesia student, for ITS student, I believe that they don't have exactly experience going to the plant area as you have already planned, Matt Leonard and also Jimmy, because you are a farmer. Even you just help your parent doing farming, but this is really nice. You got directly inside how to implement your knowledge directly to the field. I totally agree with you, Matt, that we have to give the farmer physical evidence to give them trust that if we use new investment, meaning that we use biofertilizer, we give them the physical evidence that we can give them feeling comfort using the biofertilizer. But one thing that's also based on a Matt Leonard experience, climate, abiotic factors is another things that we have also to consider. Yeah, if raining season, we cannot help them because raining season mainly get the humidity of our soil increase, meaning that another microbes can live, can grow fast. These microbes can be not our biofertilizer. This microbe can be our pathogens for our plant. This is another things that we have to consider. Season. Dealing with the farmer, we have to think many things. Abiotic factors, biotic factors, business, and environmental factors. This is a kind of become a farmer is really difficult. We have to say thank you for our farmers because farmer provide us food then. Yeah, really nice having this one. I would like to have another experience from the Philippines. Okay, I will invite Melker Gragasin Jr. Melker.
Am I audible?
Yes, you are very correct. Could you just video on if it is possible with your connection? If it is not possible, it's okay.
What is the question?
Yes, Melker, you just go ahead. What is your experience dealing with the farmer and also dealing with the biofertilizer that have already explained many from your friends? This is really enrich us. This knowledge really give us the insight.
I experienced applying the organic fertilizer only, ma'am.
Sorry?
Before applying the organic fertilizer before planting, ma'am.
You have the experience?
Apply 2 to 4 weeks before planting applying the organic fertilizer.
Okay.
And after that, the combining NPK, ma'am.
Ah, okay. What kind of the plant that you plant there?
Onion, ma'am.
Sorry?
Onion.
Onion. Okay. Onion. And how the result?
Ma'am.
Yes. How the result? You got a good yield?
It's a good yield, ma'am. Because they combining the two what? Two kinds of fertilizer. The organic and inorganic.
Okay, okay. Again, we have still to combine between two fertilizer, organic and inorganic fertilizer. Thank you so much, Melko. How I call you, Melko, correct?
Melchior, ma'am.
Okay, Melko. Thank you so much. Okay. Now I just excited to hear experience from biology of ITS dealing with the biofertilizer. Al-Fauzi already tell us about his experience when he did KP or on-job training in the ITB, correct? Yeah, in the Bogor or Bandung, for example. And how about other students from the ITS? Who has the experience? Okay.
Well, I'm so sorry. I think I'm not in on-job training in IPB. I just like collaborating projects.
Okay. The collaboration working, the collaborate project. Okay. Yes. Sorry. Thank you for correcting me. Okay. Nobody from the ITS. Okay. I have one name. This is really nice. This name. M. Zamharir. M. Zamharir. Where is it?
Yes, ma'am.
Yes, I'm Zaharim. You are from the biology. It is possible
Aye.
to video on because I didn't want to
Wait,
see your
ma'am.
face. Yes. Please, if you have no problem with your connecting, with your internet connection, please just give your face live. Yeah, I would be
Yes.
happy to see your face. Okay, Zamharir.
Yeah, sorry, ma'am. Because I was off cam before because I have a unstable connection. So for the experience about the biofertilizer, actually I don't have any experience because near in my area, there is no farm in here. So and and yeah. So then I don't have any experience for the biofertilizer. I'm so sorry.
Okay, no problem. Zamharir, if you are as one expert, you are the biology expert, and somebody asks you to explain to the farmer, for example, based on your knowledge, how you explain. Do you want to explain the farmer that better use bio fertilizer compared with the chemical fertilizer? Can you encourage how you can encourage the farmer?
Yes, ma'am. Maybe I can make some like a demonstration for them, and we can compare the result from the if we use the NPK only and if we use the biofertilizer and the NPK. Maybe like that.
Okay, okay. Thank you so much, Mas Jamharir. Okay, now I just go ahead again with my PPT. I will now do a share screen again. For the one is biofertilizer here. Nah, okay. Have you got my PPT in front of you? Okay, good. Now this is the last slide about the advantages and disadvantages for using the biofertilizer for our farming area. Okay, that I mentioned before. Now since 2020, I'm quite busy with the one research center in ITS, Agri-Food and Biotechnology, since they are established in January 2020. And why we establish agri-food tech here in order to increase and expand ITS role in food and medicine security. Because we were just thinking, because we ITS should be not going to the farming area because we don't have agriculture faculty, for example. But why ITS has this research center, which is really dealing with the agri-food and biotechnology? Now we just take a look our roadmap here. Our roadmap is really dealing with the technology. Even we don't have agriculture faculty or pro-study program, but we can invest our technology for agriculture. Because now everything using technology, industrial revolution 4.0 is correct. Now we are going to 0.5. Yeah. Now we are dealing with the technology. What is it? If we have 4 big roadmap, one is about the technology for plant and animal breeding. We are dealing with the in vitro and in vivo technology in order to produce seed and the propagation. And also we are dealing with the genetic engineering technology. Now we in the biology department as well, we have many experts dealing with this molecular, and we have one expert dealing with the plant. They're just trying to get the gene who can stand with the really, what is it, really, who can stand, the plant can stand with the really uncomfortable situation. For example, salinity, less water, this expert really dealing with this gene. Okay, another one is technology for cultivation and suboptimal land use. You can see here biofertilizer. The project that I have already explained to you today is really dealing with this project, dealing with the biofertilizer. And we also dealing with the urban farming toward precision agriculture. And we also dealing with the environmental engineering and cultivation technology for agriculture. And another one is about the post-harvest and food processing technology. What is it exactly? We are dealing how to use biomass, waste biomass, becoming something, okay, something worthy. This waste biomass, we convert them and become more economical value. Example like that I explained already, how we use the waste of backlog becoming the medium for planting brassica. And also we also talk about the packaging and the processing and preserving the food and herbs, and also mechanization. I will give you one video about the mechanism. Now we are going with the IoT, Internet of Things, dealing with the agriculture. And we also, for the technology and food medicine security, we go to the food hub digital marketing. And also we try to find one compound from the plant who has pharmaceutical effect for our health. The biology is really dealing with this one. Ibu Nailis is also one committee of this project of our program now, is one expert of how to find good compound pharmacological effect. Okay, this is Agri-Food Tech. You can meet us through this email, and you can check up our activity through this website, and I will show you this YouTube as well to what is it exactly in this what we have with the Agri-Food Tech. Please give me time to play around with this video. Please wait a minute. What is it, Mbak Nurul? Are you there? Mbak Nurul Fitri?
Yes, Buma,
Can
yeah.
you help me? Yeah, can you help me to play the YouTube about the
Ibu.
Agri-Food Tech? Have you got my link? Or I can, should I share my link to you?
Yes, Bu Maria. Wait a moment.
Okay. You can see what is it, the agri-food tech exactly. And if you have the opportunity to visit us, I'm so sorry, now we have a praying time. I just close this praying time. Okay. Because we are Indonesia, we have 5 type of praying time. We have already notification with we call this one azan, yeah. Okay. Now,
What is the title, Bu Maya? I'm sorry.
Okay, I will give you the links. Wait a minute. I will give you the link. I send you by EWA. Okay, I send you by the chat. I can send you the chat. Correct? I can send you the chat. The link is this one. Can you just open it?
Okay. Okay. Okay, I got this video. Is it right? Oh my